The Atlantic Ocean is going to disappear. Not shrink, not get smaller, vanish completely. That vast body of water separating the Americas from Europe and Africa, the one ships crossed, the one your flight paths trace over, one day it simply won't be there. The Americas will slam into Africa, the ocean between them will slam shut, and where it used to be, mountains will rise. And this isn't science fiction or some disaster movie catastrophe. It's just the slow, unstoppable movement of the planet itself beneath your feet, a movement nothing can halt. Right now, as you listen to this, the continents are crawling. Slowly, just a few centimeters a year, about the speed your fingernails grow. But give that movement enough time, and it will redraw the entire face of the Earth beyond recognition. Today we're going to look 250 million years into the future and watch all the continents come crashing back together into one giant supercontinent, the next Pangaea. We'll walk that journey step by step, epoch by epoch, and at the very end, you'll learn why this grand reunion could become one of the deadliest events in the history of life on Earth. But to understand where we're going, we first have to understand why the ground beneath us doesn't stay still at all. The surface of our planet is not one solid, continuous shell. It's cracked into enormous pieces, like a broken eggshell. We call them tectonic plates. And these plates don't sit still. They float on the scorching, slowly flowing mantle beneath them, like gigantic stone rafts on a thick, hot stew. Deep inside the Earth, heat makes the material of the mantle churn slowly, rising and sinking, and that movement drags the plates along with it. Where plates pull apart, new crust rises from below and an ocean is born. Where they collide, one slides under the other, diving back down into the mantle, and at the point of collision, mountains grow. The continents are just passengers riding on the backs of these plates, getting carried across the planet for billions of years. And here's the astonishing part. What we're about to describe is not a one-time event. It has happened many times before. And that raises a fair question. How can we even know what happened hundreds of millions of years ago, let alone what's coming hundreds of millions of years ahead? This isn't guesswork out of thin air. The idea was first put forward by a German scientist named Alfred Wegener back in the early 20th century. He noticed something that seems obvious the moment you really look at a map. The eastern coast of South America and the western coast of Africa fit together, like two pieces of a single torn sheet of paper. Wegener went further. He found that identical fossils of ancient creatures and identical layers of rock turn up on both sides of the ocean, in places now separated by thousands of miles of water. As if someone had cut a single picture in half and dragged the halves apart. People laughed at Wegener at first. He couldn't explain what force could possibly move entire continents. But science later found both the proof and the force. The key came from something called paleomagnetism. Here's the thing. When volcanic rock hardens, tiny magnetic minerals inside it freeze in place, pointing toward Earth's magnetic pole, like frozen compass needles. And studying ancient rocks, scientists saw that those needles point in different directions than they do today, which means the continents themselves have since rotated and shifted. The stones literally hold a memory of where they were millions of years ago. Put that memory together, add precise satellite measurements of how the plates move today, add computer models of the currents in the mantle, and scientists learn to run the movie of the drifting continents both backward and forward through time. And when they ran that movie far into the past, something astonishing emerged. The Earth has a rhythm, a slow pulse, beating on a scale our minds can barely hold. Geologists call it the supercontinent cycle. Roughly every few hundred million years, all the planet's land masses crawl together and fuse into one giant mass of land, a supercontinent. And then, tens of millions of years later, it breaks apart again, and the fragments scatter across the planet, only to one day reassemble. This has happened not once, not twice. There was a supercontinent named Columbia. There was Rodinia. And there was the most famous one, Pangaea, the All-Earth, a single continent that existed around 200 million years ago, when the first dinosaurs still walked across it. It was Pangaea that later broke apart into the continents we know today. And here's the key thought. This cycle never stopped. We just happen to live in the middle of it, in the phase where the fragments of the old Pangaea have drifted as far apart as they'll get, and have already begun, imperceptibly, to turn back toward each other. The Earth is assembling its next supercontinent right now. We're standing on parts that are slowly driving toward the assembly point, so let's start the clock and ride along with them. First stop, 50 million years into the future. By the measure of a human life, that's an unthinkable abyss of time. But for the planet, it's a light warm-up. And already the map starts to drift. Africa, which has long been crawling northward, keeps pushing into Europe. And that collision does something we can already watch happening in slow motion. It closes the Mediterranean Sea, that cradle of ancient civilizations. The blue sea between Europe and Africa gradually clamps shut, gets squeezed out, and in its place, a new mountain range heaves up, an extension of the Alps, only grander. Australia, the fastest of the continents, stubbornly drifts north toward Asia, and the Atlantic Ocean, for now, is still slowly growing. But this is the calm before the reversal. Somewhere in this stretch, the planet prepares to change direction, and the thing we came here for begins. We jump further, 100 million years into the future. And here is the great turning point, the moment that decides the entire fate of the planet from here on. To understand it, you need to know one thing about oceans. The Atlantic, vast as it is starting to develop. In one of the leading scientific models, zones along its edges where the ocean floor dives down under the continents and sinks back into the mantle. Geologists call these subduction zones, and once one of them switches on in earnest along the coasts of the Americas, the reversal happens. The Atlantic stops growing and starts to close. The ocean floor is literally sucked back down into the Earth's interior. And as the floor disappears, the shores are dragged inexorably closer. The Americas, which spent 200 million years sailing away from the Old World, turn around and begin the long journey back toward Africa and Europe. The gigantic ocean that seemed to us eternal and impassable is in fact doomed. It's just closing more slowly than the entire history of humanity has lasted. And so we reach the 150 million year mark, and the Atlantic Ocean is gone. Completely. Where dark, deep water now churns, somewhere through the middle of which runs the divide between the New World and the Old, there will be dry land. North America smashes into Africa. Picture it. New York and Morocco, now separated by thousands of miles of water, crumpled together, and along the line of their collision rises a colossal mountain chain. A new Himalayas, the scar of a vanished ocean. South America, meanwhile, wraps around the southern tip of Africa, as if embracing it. The continents we're used to seeing scattered across the globe begin to close into a single clump, and the Pacific Ocean, already the largest, keeps expanding, stretching across nearly half the planet, because all the rest of the land is bunching up on the opposite side of the Earth. And finally, our destination, 250 million years into the future. The assembly is complete. Before us stands a new supercontinent. One scientists have given a name, Pangaea Ultima, meaning the last Pangaea. Though the man behind the idea later renamed it Pangaea Proxima, the next Pangaea, so it wouldn't seem like it was truly the final one. The cycle will, after all, continue past it, too. It's a single, monstrously enormous landmass into which nearly all of today's continents have merged. The Americas, Europe, Africa, Asia, fused into one giant body of land, surrounded by a single world ocean. Picture a globe where nearly all the land is crammed onto one side in a dense clump, and the entire rest of the surface is taken up by an endless, unbroken expanse of water. That, according to this model, is how the Earth will look. And the man who first drew this picture of the future all the way back in 1982 is Christopher Scotese, an American geologist who devoted his career to reconstructing the movement of the continents, both into the past and into the future. But before we go further, I have to be honest with you, because science doesn't speak with one voice here. Pangaea Ultima is the most famous, but far from the only version of the future. You see, it all depends on which ocean closes first, and that is monstrously hard to predict hundreds of millions of years ahead. There's another major model in which it isn't the Atlantic that closes, but the Pacific, the very ocean that's quietly shrinking right now by a couple of centimeters a year. In that scenario, the Americas drive the other way and collide with Asia, and the new supercontinent assembles up near the North Pole. They named it Amasia, from the merging of America and Asia. Scientists in Australia, running the numbers on a supercomputer, lean toward exactly this closing of the Pacific. And there's a third model, Aurica, where both oceans close at once and the new landmass gathers along the equator while a new ocean splits Asia apart. And Scotese himself, to his credit, said something honest about these far future predictions. Roughly, it's all pretty much fantasy to start with. We understand the mechanisms of plate movement too imprecisely to confidently peer 250 million years ahead. So keep this in mind. There will be a next supercontinent. Scientists barely doubt that. But exactly how it will look is, for now, several competing pictures. And which one comes true? We don't know. And if all of this still sounds like a distant abstraction to you, here's a fact that will bring you back down to Earth in the most literal sense. This process is already underway. Right now, an entire continent is splitting in two, and you can go see it. I'm talking about East Africa. Along what's called the East African Rift, a giant fracture running through Ethiopia, Kenya, and on to the south, Africa is slowly tearing into two pieces. The massive Nubian plate, which carries almost the whole continent, is pulling away from the smaller Somali plate, which holds the eastern edge of Africa. They're separating by only a few millimeters a year, but in the long game of geology, that counts as a sprint. Cracks and faults are already opening in the ground, hot mantle is rising, volcanoes are active. And scientists say it plainly, this is literally the birth of a new ocean. Over tens of millions of years, the rift will widen, seawater will pour in, and the eastern edge of Africa, parts of Ethiopia and Somalia, the Horn of Africa, will break off and become a separate large island, ringed by a brand new ocean. This is exactly how the Atlantic Ocean itself once began. First a rift, just like the East African one, then a narrow sea, then a whole ocean. The very same force that will tear Africa apart pulled the Americas and Africa apart millions of years ago. You're living in the moment when the planet, right before your eyes, is both cracking apart and slowly reassembling. And now, with the supercontinent fully assembled, the darkest and most gripping part of the story begins. Because the arrival of such a landmass doesn't just change the map, it could become a death sentence for most of the life on land. And this isn't empty talk. In 2023, an international team of scientists led by Alexander Farnsworth of the University of Bristol ran the first detailed climate model calculation of what the weather on Pangaea Ultima would actually be like. The result was frightening. By their estimates, up to 92% of this supercontinent's land would become uninhabitable for mammals, that is, for creatures like us. Almost the entire future landmass, a dead zone. To understand why, we need to break down 3 blows that will hit the planet at the same time. The scientists called it a triple whammy. The first blow is the sheer size of the continent. When all the land is fused into one colossal mass, Its interior regions end up thousands of miles from any ocean. And the ocean is what softens climate, brings rain, keeps the land from baking and freezing. In the very heart of the supercontinent, there's no sea at all, in any direction. And that deep interior turns into a monstrous, scorched desert, where the daytime heat is unbearable and moisture almost never reaches. By various estimates, around half of the entire supercontinent will become bare desert. This effect is called continentality, and on its own, it already makes the middle of the continent a hell. The second blow comes from below. When the continents crawl together and collide, it ignites tremendous volcanic activity all over the planet, and volcanoes throw colossal amounts of carbon dioxide into the atmosphere. That same CO2, the greenhouse gas that traps heat. By the team's calculations, its concentration could climb from around 400 parts per million today to more than 600 in the deep future. And that will make the whole planet noticeably hotter. The Earth will pull a thick thermal blanket over itself that won't let it cool. And here's the important thing to understand. This is not the warming that humans are causing today. It's a natural, geological process built into the very mechanics of assembling a supercontinent. It would happen even if humans had never existed. And the third blow comes from above, from the sun itself. Here's a fact few people know. Our sun is not constant. Over billions of years, it slowly grows brighter and hotter. 250 million years from now, it will shine noticeably stronger than it does now, and pour more heat onto the Earth than it does today. Add it all together, the scorching core of a giant continent, an atmosphere overloaded with carbon dioxide, and a brightened sun, and you get that triple whammy. By the scientists' calculations, most of Pangaea Ultima will sit at temperatures of 40 to 50 degrees Celsius, and on some days even higher, all of it on top of high humidity. And here lies a truly lethal detail. The thing is, our bodies, mammal bodies, cool themselves through sweat. Moisture evaporates off the skin and carries away excess heat. But this mechanism only works as long as the air isn't too hot and too humid. When it's simultaneously close to 50 degrees and thick with moisture, sweat stops evaporating, and the body loses its only way to cool itself. It begins to overheat from the inside, and no shade and no wind can save it anymore. That's exactly why scientists put it so bluntly. The combination of this heat and humidity would, in their words, seal our fate. Mammals are warm-blooded. We constantly need to shed excess heat, and on Pangaea Ultima, there'll be almost nowhere to shed it. Most of the land would become a hostile wasteland with no food, no water, and no escape from the heat. That is the recipe for a mass extinction, one of the largest in the planet's history. But before you get completely depressed, let's restore some balance, because this grim picture has another side. First, this is not the end of everything. Even in the harshest calculations, some part of the supercontinent, narrow strips along the edges, right by the ocean, and the cooler margins, remains livable. By various estimates, somewhere between 8 and 25% of Pangaea Ultima's land would still be habitable, compared to about 2/3 of the land today. So life, in all likelihood, won't disappear entirely. It'll huddle into those last oases and cling to them. Second, the scientists themselves honestly note, maybe by then evolution will have produced some special, ultra-hardy mammals adapted to that furnace. We do, after all, see creatures living in the Sahara today. Or maybe mammals will be replaced altogether by something else, reptiles, or beings we can't yet imagine, better at tolerating heat. Life is astonishingly inventive. And third, remember, all of this is true only for the hottest model, a Pangaea Ultima at the equator, ringed by volcanoes. If a different scenario comes true, like a cool North Pole-centered Amasia, the climate could turn out far milder. The future isn't written yet. The Earth has several very different fates in reserve. And yet this grim version of the future has one frighteningly heavy piece of evidence behind it, because the Earth has done exactly this before. This isn't just a model on a computer. Remember Pangaea, the previous supercontinent that assembled around 250 million years ago? Its assembly coincided in time with the most terrifying event in the history of life on our planet. It's called the Great Dying, or the Permian extinction, and it happened roughly 252 million years ago. It wasn't one of the extinctions, it was the worst of them all, worse even than the one that later wiped out the dinosaurs. By scientists' estimates, around 90% of all species on the planet vanished. 9 out of every 10. In the ocean, up to 96% of species died off. Marine life was nearly erased entirely. On land, about 70% of vertebrates perished. The Earth very nearly turned into a dead rock. And here's what matters. One of the causes is thought to be precisely the giant volcanic outpourings tied to that supercontinent era. They hurled monstrous amounts of carbon dioxide into the atmosphere, baked the planet, and poisoned and suffocated the oceans of their oxygen. Notice how ominously that rhymes with the forecast for the future. Volcanoes, CO2, overheating. The Earth has already been through this scenario once, and barely survived. So the scientists' warning about Pangaea Ultima isn't an empty scare story. It is, in essence, an echo of something the planet already did to itself once before. And so we come back to the beginning, to see the whole picture at once. Over these 250 million years, the Atlantic will close, the Americas will smash into the Old World, the Mediterranean will vanish under mountains, East Africa will break off and drift away, ranges taller than today's Himalayas will rise, and all the rest of the planet's land will fuse into one searing continent, surrounded by a single, boundless ocean. And the most sobering thing of all is to realize that for the Earth, this is not a catastrophe, and not an ending. It's simply one more turn of a wheel that has been spinning for billions of years and will keep on spinning. Because Pangaea Ultima is not the finale. Give it a little more time, and it too will break apart. The fragments will scatter across the planet again, new oceans will be born, and one day, hundreds of millions of years later, it will all begin anew. Another supercontinent will gather, one that none of us will ever see. We tend to think of the map of the world as something permanent. The outlines of the continents on a globe, the shapes of countries we've known since childhood, feel eternal and fixed. But that's an illusion, a deception the length of a single human life. In reality, beneath our feet, everything is moving, everything is flowing, everything is temporary. The continents that exist now are just one single frame from an endless film the Earth is running for itself, with no audience and no end. And when the next Pangaea gathers, and its dead heart blazes, and its new mountains rise, there will be no one left on the planet who remembers that there were once an Atlantic Ocean, and a Mediterranean Sea, and 7 separate continents, and creatures who called all of it home.